All right, this is going to be the second half of 1.5. We're going to discuss the zeros of functions, the even and oddness of functions, and really we're going to get deep into some algebra stuff here, working hard to try to be able to factor some of these things and work through them. So first thing, when we're trying to find the zeros of functions, and you have an x squared and an x, there's no way that you can move around enough stuff to be able to solve this. You're going to have to use some form of factoring, and if factoring doesn't work, then you're going to have to use the quadratic equation, and we'll talk more about that here soon, but you're going to have to do something with that. So let's try factoring this first one, and instead of just starting it off and taking it and going, okay, I got 3x and I got x, and I'm just going to guess at what the end is, let's do a method which Ms. Viatric has called the slide and divide method. So the first thing we're going to do is we're going to take the first number that's out here in front of the x squared, which is really the problem number because it gives us so many different options, and we're going to slide that to the end and multiply it by a negative 16 and give us a new function which is x squared plus 22x minus 48. And we're going to set that equal to 0 because we want to find these zeros. And anytime you're wanting to find the zeros, you're going to look for where is f of x equal to 0. So now that I have this, the first part is nice and easy. I've got x and I got x. And the second part is just what are all the different ways that I can multiply together to get 48. So I like just starting 1 and 48, 2, 24, 3, 16, 4, 12, 5, there's not one, 6 times 8. And that's all the different combinations until we just start flipping them back and forth. Now I'm going to look at this right here. That negative around 48, minus 48, tells me that I need a negative 48. To get a negative 48, one has to be positive, one has to be negative. Well, rather than just trying all the different combinations, I'm going to look at the middle sign now. And when that one's positive, these two numbers here have to add together to be positive, which means the bigger one must be positive, which means the smaller one must be negative. So I'm going to go ahead and make all my smaller numbers here negative. And now I'm looking for which term adds together to equal 22. And the only one that works for is a negative 2 and a positive 24. So negative 2, positive 24. Now, this is slide and divide is what the method is called. Slide is where we slid that thing over at the beginning. And now we're going to divide. We're going to divide that 3 back out. So I'm going to divide both of these terms by 3. First one, 24 divided by 3 is equal to 8. And then the second one, 3 doesn't go nicely into 2. So I'm just going to slide it back to the beginning here and have 3x minus 2. And that would be the thing completely factored to where if I were to FOIL this back out, I would end up with what I started with. All right? Which is nice. That's the whole thing factored. But I'm actually going to stop a little bit before that because I want to know what the zeros of my function are. And if I stop right here where I'm at x minus 2/3 times x plus 8, where I've just divided by 3 and I haven't slid that 3 back over, I think it's even easier to see what my zeros are because I'm just thinking what would I plug in here and what would I plug in here to make this term equal to 0. Well, x minus 2/3 is equal to 0 when x is equal to 2/3. And x plus 8 is equal to 0 when x is equal to a negative 8. So there I have my zeros for this function. Good? And that is the slide and divide method. It works with a lot of different ones. You're going to get some practice with it on the homework. Next one is even more fun. Oh, it's so great. When it's x cubed, x squared, x, and then a number, you don't have anything common in these that you can factor out, and you don't have any way to just factor it into two binomials. So what we're going to have to do is we're going to have to do what's called factor by grouping. So if I have f of x is equal to x cubed minus 4x squared minus 9x plus 36, I'm going to do what's called factoring by grouping. And the factor by grouping process first requires us to group things that have like terms. So these first two here have some things in common. And then the last two I want to group together. But this negative, this minus right there, needs to go with the 9. So I'm going to change that to a plus a negative, which is really the same as minus, but now that negative goes inside the parentheses with my 9x. Now, what's common in my first term? Well, there's an x squared in both of those, and that leaves me with x minus 4 on the inside of that parentheses. Then plus, what's common here? Well, there's a 9 common in both of them, and so if I take a 9 out, I'm left with negative x plus 4 on the inside, which if I look, man, those are really close to each other. All I would need to do is take a negative 9 out, and then I would have positive x and a negative 4. And if I do that, now I have the exact same things on the inside, x minus 4 minus 9 times x minus 4. And I want to know, when is this thing still equal to 0? Well, I'm going to do a little bit more factoring out of common factors. If I look, there's an x minus 4 on both of these terms. So I'm going to take this x minus 4 out, and I'm going to bring it to the front and take it away from both of those terms. So now there's this x minus 4 out in front, and there is now what's left inside. Well, there's the x squared off of the first term, and there's the negative 9 off the second term. And if I were to FOIL this back out, I'd end up back with what I started with. And so therefore I want to know, when is this equal to 0? So same thing I did earlier. When is x minus 4 equal to 0? Well, that's when x is equal to 4. And then when is x squared minus 9 equal to 0? Well, add 9. When is x squared equal to 9? Square root both sides, and I get x is equal to plus or minus 3. Remember plus or minus there, because really there's 3 answers to this. X is equal to a negative 3, a positive 3, or 4. There's 3 x-intercepts. There's 3 solutions to this equation. And that's important because the exponent that I originally started with was cubed x to the third, which tells me there's going to be 3 solutions. Good. Now, last one, number 3 here. I want to know, when is the square root of 3x minus 2 equal to 0. And so I need to get rid of the square root, which means I need to square it. And if I square both sides, 0 squared is still 0. And I want to know, when is 0 equal to 3x minus 2 now. Add 2. And I have 2 equals 3x, divide by 3, and I have x is equal to 2/3, which if I plug that back in, it's good to see that it will be 0. And the reason, just real quickly, not to get too far into this, the reason that that works so well is because if I have 3x, if I have the square root of 3x minus 2, that's really 3x minus 2 raised to the 1/2. A square root is just what's called a fractional exponent. And so if I square all of that, I multiply together 1/2 times 2, because if I'm ever having exponents being raised to each other, they're multiplied. And so 2 times 1/2 is just 1, so they cancel each other out, and I'm just left with that 3x minus 2. That went a little bit longer than I was expecting, so we're going to go ahead and cut that as one video right there for zeros of a function, just graphing stuff, and then I'll wrap up the rest of it in the next video.